We are going to take a look at 9.3. We're just adding one more piece on to what we were working with 9.2, which was finding the axis of symmetry. So we're going to use our formula, negative b divided by 2a, or we've been writing it as negative parentheses over 2 parentheses, and then we can fill in our a, b, and c. So that'll be for our axis of symmetry. And then to find our vertex, we're going to take the value that we get when we solve this. We're going to get a number. And we're going to take that number and replace it for x, and then evaluate. And that's going to give us our vertex. And then finally, today we're adding on the y-intercept. And today we are going to discover what the y-intercept is from standard form. And it's very, very easy. Maybe one of the easiest things you will have ever seen in the history of forever. So let's get started with our axis of symmetry. Remember that we have A, which is 1, B, which is 4, and C, which is 2. So our A, B, and C from standard form, I'm going to fill that into my formula. So I have B on top, which is 4, and A on the bottom, which is 1. And when I evaluate this, I end up with a negative 4 over 2. And then that reduces to a negative 2. So my axis of symmetry, that was the first thing I was finding. We write it as an equation, x equals negative 2. We are going to use that by plugging it in. We're going to replace x in our original equation. This is 4 times x plus 2. And we are going to replace x with this negative 2. And then we start to evaluate. So negative 2 to the second power is 4. 4 times negative 2 is negative 8. And then this plus 2 comes down. And then we are combining all of these to find that y equals negative 2. So when we plugged in x of negative 2, we get out a y of negative 2. So this is our vertex. I'll highlight it in red. So here's our vertex. Our axis of symmetry, I wrote in blue there. And then finally, our y-intercept. And I'm just going to write this in the space underneath. So our y-intercept. This is the easiest, this is the new part today, but it's the easiest thing you'll have ever done. From standard form, our y-intercept, which is the place where it crosses the y-axis on a graph, so it'd be like this spot right here. The y-intercept is simply our c value. So our y-intercept, we're going to write it as a point though. It's when x is 0, y would be 2. It's our c value. So I know some people were asking, well, what happens to the c? That's what the c does. We can tell what our y-intercept is. Because if I made x 0, if I were to make x 0, this would cancel out and this would cancel out, and that's why we're left with just the c. Let's take a look at another example. I'm going to find my axis of symmetry first. Remember that's negative b over 2 times a, so I'm going to replace, I have my a of 1, my b of 2, and my c of 4. So I'm going to have 2 on top, 1 on the bottom, negative 2 over 2, which reduces to negative 1. So my axis of symmetry, x equals negative 1. I'm going to plug that back in. So a negative 1 goes in both of these places, and then I'm evaluating. So y equals, this will make a positive 1, this will make a negative 2, and this is still 4. And then when I put all of these together, they make 3. So my vertex is my x value, negative 1, comma my y value of 3. And then finally my y-intercept, I'm just going to write y-int, is when x is 0, y is 4. And again, we're just pulling that from our c term. So our c term is what goes here. We're always going to use 0 for our x, and then we're always going to use c for our y there. Not so bad. So we can tell our y-intercept here is 0, 10, just by looking at it. But let's go through and we'll do the other pieces first. So I'm going to have negative b over 2 times a. So that's going to be a 6 in here and a 1 in there. So negative 6 over 2, which makes negative 3. So my axis of symmetry, x equals negative 3. We're going to replace x with that. So I'm putting a negative 3 in here. Now the hardest part probably of all of this is just making sure we evaluate correctly. Negative 3 times negative 3 makes a positive 9. 6 times negative 3 makes a negative 18. And plus 10. And then we're putting all 3 of these together, which would give us positive 1. So for my vertex, when my x is negative 3, my y is 1. And then my y-intercept is 0, 10. And we could graph a parabola just using these two pieces of information. Oh, 3 pieces. Because our axis of symmetry, our vertex, and our y-intercept. With just those 3 pieces of information we could graph. So let me show you some more complicated ones. Negative b over 2 times a. My b is 4, my a is 2 now. So this is going to make negative 4 over 4, which reduces to negative 1. So my axis of symmetry, x equals negative 1. I'm going to replace x in my equation with a negative 1 and evaluate. So negative 1 squared is positive 1, and 4 times negative 1 is negative 4, and then I'm still bringing this 2 down. I haven't used that up, and I'm still using this plus 3. I'm going to multiply these together to make 2. 2 times 1 is 2. And I'm going to put these together to make negative 1. And then 2 minus 1 is 1. So my vertex, x was negative 1, y is positive 1. And then my y-intercept, if x was 0, y would be 3. And I'm pulling that 3 from there in green. Super, super simple. Just do a couple more examples. Negative b over 2 times a. In this case, our b is a negative 8 and our a is a negative 1. So the opposite of negative 8 is positive 8. And 2 times negative 1 is negative 2. And this is going to reduce to a negative 4. So x equals negative 4 is my axis of symmetry. So I'm replacing x with a negative 4 and a negative 4. So this negative and parentheses are going to stay, and I'm going to work out negative 4 to the second power, which is 16. I'll write that in red. And then negative 8 times negative 4 is positive 32. And then negative 15 comes down still. I'm going to apply this negative to the 16, so y equals negative 16. And let's put these together, and this would leave us with 17, positive 17. And when we put those together, y equals 1. So for my vertex, when x, I meant to write it like this, when x is negative 4, my y is 1, and my y-intercept, when x is 0, y would be negative 15. And we're just pulling that again. This negative 15 is coming from our c term. Let me show you one more example. I'll do it with this one. It's got large numbers. negative b over 2 times a. My b is 24, my a is negative 3. So I've got negative 24 over negative 6, which reduces to positive 4. So with a positive 4 there, our axis of symmetry, x equals 4. So we're going to replace here, y equals negative 3. So our numbers are large, but still manageable. And I'm replacing now with a positive 4. So y equals negative 3, and then I'm working out 4 to the second power, which is 16. 24 times 4 should give us 96. So plus 96 minus 47. And so now we're working with negative 3 times 16, which will give us a negative 48. And then if I put these together, that's going to give me a positive 49. So y equals 1 when we put those together. So for my vertex is 4, 1. And then my y-intercept, which is the new piece today, is if x was 0, y would be our c term out of a, b, and c. So I have a, b, and c. So my c term is negative 47.